All right, so I'm going to pull up some of the Vert stuff that I have made, and we're going to look at nested KVM. Is that all right? Can you guys see it in the back? Okay. Good. Okay. So this is Horizon. It's the web interface for OpenStack. So what you guys will log into to launch images and stuff like that. We'll take a look at it. Oh, now arrows are working. Hang on a second. There we go. So the plan is for each student to essentially have their own project, which gives them their own network. In this case, because of the number of people that are going to be using it and the limited resources on the cluster currently, we have everything in one project. So up here you can see access to the project name, being logged into the admin. I also have access to the admin project. So I'm going to switch over to that real quick so we can look at a couple of the back-end pages. So if we look at hypervisors, we have 6 hypervisors running, and it'll give you stats on CPU, RAM, and storage. Storage is going to be total since it's clustered across all of the hypervisors. And you can see a number of instances are being run. From the admin perspective, we can look at all of the instances that are being run. An instance for you guys is basically a VM. So I have 3 of them in the Vert class, and then I've got an NFS server left over from a previous project that I was looking at. So we'll switch back. So for the Vert 1 class, we have 1 image that's in the project. It's a CentOS 7 GUI. It's going to be a VM template that you guys can launch. We'll look at that in a second. And there is 1 other shared with the project, and this is going to be just another CentOS 7 with no GUI. It's a infrastructure install. This is what I use to create the NFS file server. So on the instances page, you can see that we have 2 IP addresses. We've got the private IP address that I talked about, which is the 192.168.112/24. So that's going to be how the VMs communicate with each other. It's the address that they see internally. We'll look at that. So we can assign a public IP to these, which is going to be on the sandbox side of the network. So that's going to be the 10.238.253 addresses, and that is how you connect to the actual instances. So look at that. XRDP takes a second. But so the CentOS 7 VMs are set up for both SSH and for RDP connections since they have a GUI. So just to check addressing, so I ping Google so we can get out to the internet. You can see that when I look at the interfaces, F0 has that 192, the private address, and it's using jumbo frames. Just I didn't mention that from a networking standpoint. Everything back there is running jumbo frames. So that makes transfer between VMs, storage, replication, all that makes it a lot faster because you have less packets. So here's the other instance that I already built. You can see here it's the Vert student instance that I'm logged into now at the 253.45 address. So I have a VM running on this. We'll see how many commands I get wrong from memory. Or, okay, maybe I don't have one running. Let's check the GUI. There we go. All right, so we're going to look at building that on another server. I know it's hard to read, but just a real quick demonstration of this is going to be KVM inside KVM, so nested virtualization here. The nested VMs are quite slow. It does run better using a VMware compute node. So out in industry, that's some of the things you have to take in consideration, what you're going to be doing with your cluster. Basically, nested virtualization is the most strenuous thing you can do. Most of the time in a data center, you're not going to have nested virtualization. That's why people that have had the cloud class where they're working with Hyper-V in all the labs, you can't actually even start the VMs. So this does quite a bit more. If we have time, I'm probably going to launch an ESXi instance. We can run ESXi here. It does require shared storage, which we'll take a look at also in a second. So I'm going to start building this out and see if I can get through it pretty quickly on the other instance. All right, so from here, all I have is just a base CentOS install. I've uploaded a couple ISOs to it. I don't have QEMU, KVM, anything like that. So we're going to look at that real quick. Yeah, if you notice in the command, we are using sudo here. By default, there is no root password assigned, so you're only going to be able to connect through the account that Cloud Init creates. So whenever you launch an image, these images have all been pre-configured with software called Cloud Init, which what that does is basically sysprep the instance. So it gets a new MAC address, all the DHCP, DNS, all that information that you would normally see on an already existing image is wiped out. Everything is shrunk, and then it allows for resizing of partitions, file systems, so you can take an image that's got an 8 gig disk and tell it to have an 80 gig disk, and it will resize automatically. I actually broke that on this image creation, so it resizes, but then we had to resize the file system manually. It's in the lab. You guys will get it. So we've installed the KVM packages. Let me pull up notes here. All right, so we're basically going to run through like the first lab that you guys get. Which looks like I did already. So we've already set this for bridge 0. I'm going to switch to root. That's why it's already done. Hang on just a second. There we go. So I'm running the install command again because I accidentally drugged the wrong VM over there. So pay attention to what you're connected to. So the commands right before that, I've assigned just a password to root user so I don't have to type sudo all the time. That's all that does. You guys don't have to worry about the specific commands, all the stuff that's in them, because it's all in your lab document, just kind of demonstration on what's happening. All right, so now we're back to network configuration. So what we're doing there is configuring our interface for bridge network, and we need to allow forwarding from there. We're going to use a custom directory to build VMs in. So we have to tell SE Linux about that. You are running SE Linux and Firewall D here. And in this case, this will be in your next module, but we're going to let it use NFS shares. So I have an NFS share here. This will take a minute. There are a couple parameters that we have to set for KVM for nested virtualization. So those will be next. Basically, we have to tell it to allow nested virtualization, and then there's some CPU memory addresses that we'll ignore. So basically what we've done here is those configurations have told KVM to run nested VMs. Otherwise, they have problems starting. All right, I'm going to switch over to the GUI so I can add some storage contexts because I don't remember the commands for it. All right, so here is what we ran the install for already, the KVM package. We've got virtual machine manager, vert viewer. We can create VMs from either the GUI or the command line at this point. So you can see that our default path is going to be images. And I have a pre-built NFS share attached here. So we're going to add that so that it'll be able to use it for storage. So this is why I switched over to the GUI. It's going to complain that where I have put these images to, the libvirt user doesn't have access to. There is a command line way to do that. I don't remember what it is. I'll have to add it to the lab. One thing of note here, when you're looking at vCPUs, virtual CPUs in OpenStack, where we saw the list of how many CPUs there are by hypervisor, whenever you assign a vCPU to something, that you're talking about a thread, not an actual CPU. So pretty much all your virtual machines are going to have two or more, all your nested virtual machines are going to have two or more CPUs allocated to them, because the way it runs through the stack is this CPU count is equivalent to a thread. All right, so let's look at this from the command line, which is what your first lab's going to be in. I'm going to look at your lab document real quick. Do I have to tell it the full path? It's still not going to let me tab it out. All right, I'm going to build it from the GUI just so we can see it. I did it from the command line earlier. And we'll build a disk on shared storage. That's not what I want. So here's where you'll start to see performance degrade just a little bit, where you're looking at nested virtualization. You can see the boot up for disk and for the CPU path is fairly slow, or it's considerably slower than base KVM. However, if you consider the path that we're actually taking here to get to physical hardware, it's fairly impressive. So we'll look back at the dashboard. So we have this instance here, shared storage for CentOS, and we have this instance. Those are virtual machines running on top of KVM. Inside this VS2 is where we installed the KVM module. So you got KVM on KVM, and then a 64-bit VM on top of that, which was a few years back, like 3, was not possible. And then we're actually communicating with a mount to this other VM for shared storage. So to get back to hardware for that, you've got basically double to triple the write operations, and then you're going through 2 virtual CPUs before you hit base CPU. So this shared storage VM, the way I built it, is it's just a base CentOS image. It's got an 8 gig root disk. One of the nice things about OpenStack, and you can do this, it's easier to show with a Windows server, but I don't have one running for the network servers class. But I've attached a volume. I've attached a terabyte volume to it, which is what you guys are going to use for your shared storage portion of the module. So I've just gone in there and set that up as an NFS server. So it sounds pretty simple, but it's basically creating block storage on the fly.